team. Now let's talk about polarization. Okay, so polarization, when it comes to polarizing lens, it means that we are, for an electromagnetic wave, it is basically giving it a definitive direction relative to the direction that the wave is propagating in. Basically, if we have an unpolarized light, like this one right here, and this unpolarized light has many electromagnetic waves at different directions. And let's say that we give it a name, that is the initial intensity 0. All of a sudden, it passes through a filter. That filter is only going to get a little bit of that electromagnetic wave. In fact, it's going to cut the intensity of that electromagnetic wave in half. That always happens for the first filter. If we have an unpolarized filter and it goes, or a polarized ray and it goes through a polarized filter, this is always the equation. Okay? Now for this other part right here, it is basically, hey, you're passing through the same filter at the same angle, but there's no angle involved in it, so it's 0. So the angle is 0. So we use the actual equation right here for the intensity number 2, 0 squared. Okay, realizing that intensity number 2 is equal to intensity 1, because intensity 1 is this one right here. This is intensity 0. And this is intensity 2. Since there is no angle shift or just shift angle, there was no actual intensity change in it. Now let's look at this other part right here. The same goes. So we have initially intensity, the initial unpolarized intensity, which is intensity 0. Then it passes through a filter. Now for intensity 1, in this direction, it is cut. Now the intensity is cut in half. But now we have an angle right here. And this angle is with respect to the initial angle, the initial polarizing filter that went through. And this is I2. Intensity 2 equals intensity 1 times cosine squared of the angle right here, this angle right here that has formed. Okay? And that is and also, like, for this angle right here, it's important to remember the angle theta is the difference between the angle of the first filter and the second filter. Of the first filter, this first filter, and the second filter. So in actuality, since this filter, we're assuming right here, since it starts here, the angle is 0. Therefore, what we're actually looking for is the angle that's coming over here is angle theta 2 equals the angle minus 0 degrees to get the actual angle that goes here. Okay? All right. Now for this one, this last one right here, let's focus on this one. So we have intensity 0. It's unpolarized, completely unpolarized. Remember those words, it's unpolarized intensity. Or intensity, like unpolarized ray, so its intensity is 0. It's a complete intensity. And now it's going through a filter. This angle is still 0. The angle is 0. And now this one right here is 90 degrees. 90 degrees. Because we have a 90-degree angle, notice that as we're going through, and putting in the number, the degree in, cosine of 90 is 0. So the intensity, once it passes through here, and let me just mark this. Once it passes through here, is actually now 0. And it is 0 because this angle right here starts at 0. So 90 minus 0 degrees is 90. Cosine of 90, cosine square of 90 is still 0. Okay? So I focus a lot on the math part here because it is a little bit tricky. But I picked some good problems for us to go through. Alright, so if you have a completely polarized light of 150 watts per meter squared, immediately it's telling you we are starting off with a completely polarized light. So it's no longer, we can no longer use this equation per se, because it's already gone through. This is I0 is on polarized light. Now we're dealing with I1 immediately. So the intensity 1 immediately. So what will be the intensity after passing through a polarizing filter with its axis of 90 or 89.0 degrees from the light polarization direction? So if we write a diagram, let's do this. This is the intensity, 0. This is unpolarized light. It goes through a polarizing filter. Okay, so we have this. Now this is the intensity that we're dealing with. I1 is equal 150 watts per meter squared. Okay, and we're starting off, we're starting off, it's kind of ugly, let me erase this. We're starting off at 0 degree angle. A 0 degree angle. Okay? And then we hit it another polarizing filter. This is P2. Let's put P1 here. And this is P2. Let me color it. Polarizing filter number 2. And this polarizing filter now has an angle from here to here that is 89 degrees. So now this second one, this intensity that we're looking for, we plug in I1 cosine square of theta, and this theta right here is 89.0 degrees. And with that equation per se, we can solve for the intensity after it's passing through that polarizing filter, and that intensity is equal to 0.0457 watts per meter squared. Hopefully this was revealing. Well, let's do another one. Let's do this one. In this one, it is 3 filters. Okay, so show that you have 3 polarizing filters. So let's start off with doing the full polarizing filters. 1, a 2, a 3. Oh, that was an ugly filter. Okay, there you go. 3 filters. Okay, with the second at an angle of 45 degrees to the first. Okay, so we start here. Okay, and it's saying this is 0. This is the first polarizing filter. Let me put it P1, P2, and P3. Okay, so that's 0 degrees, but it's saying that it is 45 degrees to the first. Okay, so we start 45 degrees to the first. So now we have 45 degrees here. Okay, And then it's saying that the third has an angle that is 90 degrees from the first. So we do, okay, so it's 90 degrees from the first. So that is 90 degrees from the first. So let's start off. It's saying, finally, it says, prove that the intensity of the light passed by the first will be reduced to 25% of its value. So intensity of the first, or intensity on polarized filter. Okay, then it hits and becomes intensity 1, then intensity 2, and then finally intensity 3. Okay, so passes through the first filter. That first filter is intensity 1 equals 1/2 intensity 0 of unpolarized filter of polarized intensity. Okay, and then this one right here is I2 equals I1 times cosine of 45, and this is squared. Okay, so basically I get this. So I replace this part right here with this 1/2 right here, and this becomes square root of 2 over 2 squared, finally becoming I2 equals 1 over 2 I1. All right, that's the first one, or that's the going through the second polarizing filter. Now for the third polarizing filter, we do the same concept. I3 equals I2, and this time around it's saying that it's 90 degrees. But remember, we're looking at this one, okay? So it is actually cosine squared of 90 degrees minus 45. Minus 45, because as I said before in this one, just to reiterate, that the angle theta is the difference between the angle of the first filter and the second filter. I said that a little bit incorrect. It's the angle of the previous filter and the current filter. So we're here, this is the previous filter, and this is the current filter. And therefore we have I squared, or I2 cosine squared of 45 degrees. We plug in the numbers. If we plug in the same numbers that we did before, I3, and replacing I2 with 1 over 2 I1, and then taking this and converting it to 1 over 2, cosine squared of 45 is 1 over 2, then you get, at the end of it, 1/4 times I1, meaning that it is 25% of its original first polarization. Boom. Answer. Hopefully this was helpful, and on to the next video.